How can a neutral object become negatively charged? Well, first we have to look back to the structure of an atom. Inside the nucleus, you have positively charged protons, an equal number of neutrons, which have no charge, and negatively charged particles called electrons that move around in orbitals, kind of like how planets revolve around the sun. A simplified model would look like this, where you have in a neutral atom the same number of positively charged particles as negatively charged particles, resulting in a net charge of zero. For a positively charged atom, you must have a net charge greater than zero. This means you have to have more positively charged particles, protons, than negatively charged particles, or electrons. Since protons are pretty tightly held to the nucleus, the easiest way for an atom to have more protons than electrons is to lose an electron. To understand why an atom would be willing to lose an electron, we must look at the valence shells, or the outermost shell of that atom. Depending on which orbital, it wants a certain number of electrons in order to be stable. In the first energy level, an atom wants to have 2 electrons. In the second energy level, 8 electrons. Third, 18, and so on. You can determine an element's number of orbitals and electrons in each orbital by its location on the periodic table. Different types of orbitals have different shapes, and they are labeled as S, D, P, and F according to their shape as they are found in the elements on the periodic table. By determining the number of orbitals and the electrons in each orbital, you can determine how active an element is. The word active in this case means willingness to either give up or accept an electron. It does not mean that you have an atom dancing around actively. Let's take a look at the example of sodium. We can see that in its outermost shell, it has 1 electron. In a two-dimensional diagram, it looks like this. Do you see that lonely electron orbiting around the outermost shell? It is longing to escape and join someone else. Enter chlorine, just one shy of its desired octet. It's wanting nothing more than to accept sodium's extra as sodium gladly donates the superfluous electron to chlorine. Sodium now has 1 less negatively charged particle than positively charged particles, rendering sodium now positively charged. The same goes for chlorine, only in the opposite. Accepting that electron now gave it more negatively charged particles than positive, rendering it negatively charged. The next time you put salt on your food, reflect on all that went in to creating that sodium chloride or table salt. So when answering how can a neutral object become negatively charged, think back to that salty meal and remember how chlorine accepted that electron from sodium, giving it that extra electron and a negative charge.